Not a single thoroughfare has witnessed more dauntless courage, heartbreak, or romance than the Gold Road of California. For this was the highway of high adventure, offering fortunes to the first men who would swing a pick to the end of the rainbow.
The parallel between the 21st century quest for space resources and the gold rush of the 1900s is often drawn. The asteroid belt is believed to contain plenty of metals, including iron, nickel, gold, and platinum, promising opportunities of generous financial gains. Looking closer towards our natural satellite, some believe that rare metals may be hidden in the lunar regolith. Antonino Salmeri from Lunar Policy Platform joined us today to shed some light on this topic. Do you think a new gold rush-like quest towards the moon is upon us, Antonino?
It's a wonderful question. And I was talking about the gold rush just yesterday exactly as an example of what we don't want to have on the moon and what some of our friends in other parts of the world dream about. And so they really would love to see the same, because for them, it's a great example of how you develop, modern society. But for others, it's a tragedy, because it implied destruction of the environment, destruction of indigenous communities. And so we don't want to do the same.
Throughout the 5 episodes of the podcast, we've had a chance to exchange with scientists, entrepreneurs, and engineers, but we have not involved the regulatory experts into the conversation yet. Stephen Freeland, professor at Sydney University and Bond University, as well as Vice Chair United Nations COPUOS Working Group on legal aspects of space resource activities, is joining the conversation, and he will tell us more about the big questions that arise when we make great plans about space exploration.
The lawyers are important, but they're just one element in a much broader thing. We need to understand the questions before we can even come up with legal or governance answers or recommendations. And to understand the questions, we need to just begin to understand all of the incredible technical, economic, scientific, cultural, indigenous perspectives that are all relevant.
I'm Hanna Siemaszko, and you're listening to Resourceful, a podcast which explores the exciting new opportunities of space resources. Resourceful is produced by Esric in collaboration with Silax.
On Earth, we have plenty of air and water, without which we couldn't survive. The situation in space and on the moon is rather different. We are not able to just plug ourselves and play. We need to bring the air and water with us, as well as recycle every little drop we produce. And this makes oxygen and hydrogen extremely precious, even if less shiny than the gold. Then there is the question of the resources that can enable us to build tools in space or on the moon. In addition to oxygen, regolith is believed to contain other minerals such as silicon, aluminium, iron, calcium, magnesium, and titanium, which are essential for manufacturing. Discovering these minerals in space would enable humanity to rely less on resources sent from Earth and thus contribute to a sustainable approach to space exploration. Moreover, continuing our activities up there and being able to stay for longer and go further brings significant benefits to our daily lives down here on Earth. Here's Stephen Freeland.
It's incredibly important that we have appropriate governance structures in place for the broad range of activities engaged in the exploration and use of space. Space is so incredibly important to every society on the planet. You and I use space every day so many times. If space was compromised in terms of the way we were able to access space, then literally the critical infrastructure in every country would collapse, and we would literally be back in the dark ages. Our transportation systems would collapse, our communication systems would collapse, our sewage systems would collapse, our electricity systems would collapse, our financial systems, agriculture, disaster management, flight transportation, the list goes on and on and on. So space is so incredibly important to every community on the planet. Obviously, in different ways, but every community. It's important that we have rules that will allow us as a humanity to pursue space in a way that is positive, is peaceful, is sustainable, and brings us as a humanity as many benefits on a global basis as possible, whilst minimizing the risks. Because with any activity such as this, there are always going to be risks. So we just have to find the appropriate way. There are many legal issues and political issues to be addressed when you put together a governance structure, but there are so many other voices as well. Obviously, there's the economic community and the scientific community and the security community. But space is also about religion, and it's about culture, and it's about First Nations perspectives, and it's about so many things. You know, space is so unique and touches us all, touches every person on the planet, as far as I'm concerned. And so, therefore, putting together governance structures in whatever shape is complex. And we have to make sure that we don't just listen to the loudest voices in the room, but we listen to every voice.
Back to basics. Let's look at what space law actually is. Space law is associated with the rules, principles, and standards of international law that address such matters as the preservation of the space and Earth environment, liability for damages caused by space objects, the settlement of disputes, the rescue of astronauts, the sharing of information about potential dangers in outer space, the use of space-related technologies, and international cooperation.
We have 5 international treaties negotiated by COPUOS around 50 years ago now, starting with the Outer Space Treaties and ending with the Moon Agreement. And then we have a number of principles, resolutions developed again by the United Nations General Assembly, but in reality it's always been COPUOS producing these norms that implement and interpret at a certain level the general rules of international space law. Now, because of the very nature of the Outer Space Treaty, it has been able to survive to the test of time, right? Because it provides general principles.
Except for these rules and principles, we also have a series of non-binding bilateral agreements between the government of the United States and governments of other countries called Artemis Accords. The accords are related to the Artemis program, whose goal is to return humans to the moon. And pay close attention to it. It is the most extensive and diverse international human space exploration coalition in history, with collaboration between NASA, ESA, or JAXA, for example.
Now, the Artemis Accords is not legislation, it's not law, it's not even binding as between the signatories. It is a set of bilateral arrangements between NASA and space agencies of now, I think, 35 or 36 other countries, which is broader than just space resources. It looks at activities and behaviours and generally in terms of, for example, the moon. But it's also obviously relevant for space resources. It's not legislation, it's not binding, but it's got some also really interesting ideas. And then we have various countries, including Luxembourg, that have passed national laws that have relevance, that purport under their national system to say to their nationals, if you engage in these activities, we, under our national law, regard you as having certain rights and obligations. But all of those national systems, they're important for what they are, but in a sense, they are still subject to or guided by the international framework. They're not divorced from each other. So we have that. We have a lot of work being done by civil society, looking at the issue of space resources. And now we have a lot of work being done at the United Nations in response to the US legislation of 2015. The legal subcommittee of COPUOS agreed by consensus, and it's now 102 member states. And Luxembourg, of course, is a very active member and a very constructive member, but it's one of 102 countries. Those countries agreed from 2017 to include what was then called looking at potential legal models for the exploration, exploitation and utilisation of space resources.
Looking at an example of international cooperation right here on Earth, we find ourselves stumbling upon the Antarctica model. There are numerous similarities between space and Antarctica, yet numerous elements that set them apart. In 1998, the Protocol on Environmental Protection to the Antarctic Treaty came into force. The treaty was signed by 56 nations and has so far proved to be extremely reliable in making nations follow the rules.
No individual country can own Antarctica, a little bit in the same model that no individual country can own a planet or a planetary surface. So there is the parallel between no political borders. That's not to say Antarctica is not politicized. So there are different sectors within Antarctica that are administered by different countries that have a land border bordering with different parts of Antarctica. So, for example, McMurdo is within the New Zealand administered sector of Antarctica. And where I've also done field work was in part of the British Antarctic administered sector, which is on the other side of the Antarctic continent. So there is more politics than this concept of non-ownership versus ownership. But there is, so to operate in Antarctica, if you want to do field work, you have to seek permission from the country in which you are traveling to do that field work. So if I'm traveling with the American teams, the Americans will work out things like field permits and what you're allowed to do and what you're not allowed to do. If I'm traveling with a British-led expedition, it will be the British government that will issue the requirements for travel. So you'd have to fill out the paperwork for environmental impact surveys, for sample collection, that sort of thing. So there are rules and regulations that have to be very strictly adhered to.
This was Katherine Joy, guest in our first Resourceful episode, talking to us about her experience as a planetary scientist and meteorite explorer in Antarctica. Now back to Katherine.
But in terms of the science that's undertaken, there is an awful lot of collaboration and cooperation. So we'll support each other's fieldwork projects. So there are often these huge fieldwork projects in Antarctica where lots of different countries will come together. They'll pool resources to achieve a common goal.
Since we can only imagine how cooperation would work on the Moon, it seems we should have some guidelines in place. Let's see what Antonino says about this.
We need to go there, do science, ensure that we understand before we regulate or as we regulate, because we cannot wait for pure scientific certainty. That will take some time, but we will need much more data. And so the data sharing, it's a completely different topic, because information sharing, it's more like from an operational viewpoint. Sharing data, it's a very difficult question. If it's a space agency collecting this data, normally there is no problem, because space agencies are public bodies, therefore they're bound by full release of their data. But even then, when you have a scientist that is looking at this data and they want to do a publication, they have a certain window of time in which they are first. So the data is shared only later. But if you have a company collecting this data, for them, this is business. It's proprietary information. Maybe some companies, their business will be just studying the lunar environment and selling data so that you can do a better mission. How are we going to go about that, right? How are we going to make sure that the fundamental breadth of knowledge we need to be safe and sustainable on the Moon is publicly shared? And how do we differentiate with the interest of legitimate operators that, have a business case and have to respond to their investors? Otherwise, they will never go on the Moon in the first place. And so there is a separate conversation about information sharing that has to be done, and that right now it's still yet to be advanced, let's say.
5, 4, 3, 2, 1, 0.
Besides the need to put rules in place and collaborate and share knowledge, another similarity with Antarctica is that everything that we bring with us on the icy continent must not remain there. With the Antarctic Treaty coming into force in 1998, there is still a lot of trash left back on the continent dating from before that year, with enforcement left at the consideration of each mission. Even though the implementation is far from perfect in Antarctica, the need for a sustainable approach to the pristine environment is gaining more and more momentum. But what about the situation on the moon?
The situation on the moon, though, it's very different because of the physics of the moon and the geology of the moon. So the moon does not have an atmosphere. Our strategy right now to dispose debris is to burn them into the atmosphere. And spoiler alert, that might not be the best strategy because of the pollution that this creates, but separate topic. On the moon, we don't even have that choice. You cannot burn anything on the moon. There is no atmosphere, meaning that you have two choices. Either you crash on the moon right now. These are the two choices that you have right now. Crash on the moon, or you go into a heliocentric orbit, and therefore you escape the gravity of the moon to go essentially crashing somewhere else, because at some point you will have to either crash or burn. What is the issue with both of these strategies, and the reason why none of them is sustainable? If you crash, this creates pollution on the moon, first, and second, it's a huge safety hazard. In 99% of the times, it's an uncontrolled crashing, meaning that you will not have the possibility to decide with precision, I am going to land, because that would be a landing. You're just saying, we are about to finish the fuel, approximately we can make some calculation, we're going to end up in this part of the moon, and then you just let it die. It's been accepted as a practice right now because we don't really have other technological solutions. In the past, it was impossible already to arrive on the moon, so let alone finding a sort of controlled disposal mechanism. And because, of course, there is pretty much nothing on the moon. I mean, besides the environment, there is no safety hazard. But if we imagine a future on the moon with many rovers, many missions, in about 6 years, humans, then you have a huge problem because you will just look up and say, oh, this thing might actually crash on me one day. I don't know. They don't know. Nobody knows. Is this sustainable? I don't think so. The other option, which is going into a heliocentric orbit, it's first of all expensive because you will need a lot of fuel and a lot of delta V to escape the gravity of the moon and inject yourself into a much more energetic orbit. Second, it's not really a permanent solution. I think this strategy was adopted by the Apollo missions, but one of them came back. So it was sent into a heliocentric orbit, and then it came back in the Earth-Moon system. It literally passed across the Earth and the Moon.
In 2017, Luxembourg was the first country in Europe and second in the world to pass a legal framework on the exploration and use of space resources. Quite uniquely, the Grand Duchy first focused on creating legislation on space resources and only later enacted the National Space Law. Here's Jean-Louis Schiltz at the Space Resources Week 2024 talking about the law.
And the main challenge was how to make sure that the legal provision, which is now Article 1 of the law, is drafted in such a way that the actors have sufficient guarantees that they actually own what they harvest in space, to put it in simple terms.
Here's Antonino.
A few years ago, Luxembourg passed legislation to say that space resources are capable of being appropriated. This is Article 1 of the Space Resources Law of Luxembourg. And in the process of passing that legislation, the Conseil d'État was asking this very question to the parliament. Like, why are you creating legislation if you're not sure that you can enforce it? How can you make sure that your interpretation of international law that says that space resources can be appropriated is the correct one? And how can you make sure that others agree with you and respect the provisions of your legislation? If tomorrow the Luxembourg Space Agency would give a license to extract space resources on the moon to a company based in Luxembourg, that's called Company X, and then the company would not respect the provisions of the licensing, then Luxembourg can exercise its own national powers in order to enforce that provision. So they can go to the company, seize their assets, fine them, take any measure that they have at their own disposal under national law. And the same could be done by any other government that enacts national legislation. And I want to emphasize that this is a key part because the enactment of national legislation or national decrees, if you don't want to do legislation, is mandatory under international law. So under Article 6 of the Aerospace Treaty, private entities cannot engage in space activities without the authorization and continuing supervision of a state, which means that there has to be some sort of mechanism, a decree, a licensing system that says you are authorized to do that and gives boundaries on how do you do that. Now, the real problem starts when you have disagreements among states. So, for example, Luxembourg gives a license to Company X to mine, let's say ice water on the South Pole of the moon. And then another company from another state comes and arrives first in the same mining site. and they start extracting the resources. Then at that point, the question is is Luxembourg entitled under international law to stop this other company from doing what they're doing? What kind of remedies do you have? And here it's where it gets tricky.
Luxembourg and the agency in Luxembourg, when it's considering an application for a license from a Luxembourg company to send something to space or whatever, understands what its obligations are at the international level and has to ensure that as part of the deal, if it is to approve this license and the private entity is to operate, to ensure that they're doing it the right thing. Okay, so there is a legal obligation. But obviously, and I think companies recognize it, we need to instill in the private sector a sense of social contract and responsibility. And I think many are trying to do that. Again, as a former investment banker, I understand the capital ideal, and companies have different bottom line perspectives perhaps to countries. And people have said that they're irreconcilable in the context of space. Well, I don't think they are.
Going back to the gold analogy again, we also tend to compare data to gold. There is far too much business that can be won by those who have access to crucial information. In order to fight unfair competition, we even punish such activities as insider trading or look closely at conflicts of interest. It is no surprise that building trust and laying grounds for proper information sharing in space exploration is heavily discussed by space lawyers.
Everybody will have different types of technology. Everybody will have different types of goals and capabilities. And so sharing of information, because in the end, the activities will be taking place in a hostile environment. It's hazardous, it's dangerous. There are all sorts of effects that may stem if we get it wrong. The sharing of information is a crucial thing.
If we are not aware of what is happening, if we're not aware of what we're doing, we cannot coordinate, we cannot cooperate, we cannot have safety, we cannot have sustainability. We don't even know if we have a problem because we're missing the fundamental information. So it is a key mechanism. Now, there is one provision in the Outer Space Treaty, Article 11, that for the longest time has been, let's say, sitting quietly in a corner, not being very much discussed at the international level. But it's becoming more and more relevant in international discussions, and take a little bit of pride in pushing about that since a few years now through another initiative called the Article 11 Project. What does Article 11 say? Article 11 says that in order to facilitate international cooperation in the exploration and use of space, states agree to share information on the nature, conduct, location, and results of their space activities by providing this information to the United Nations Secretary General, which for this kind of duties discharge the United Nations Office for Outer Space Affairs. And then UNUSA, once to receive this information, shall disseminate them promptly. So essentially, it's a hub and spoke system where every state sends a notification to the UN, and the UN redistributes them to the rest of the international community, not just to states, but it makes it publicly available for everyone to see.
It's not only information that should be shared to ensure successful space exploration. The only way to move forward is to centralize processes and find common standards. Already in episode 2, Najwa Naimi from the Exploration Company talked about the crucial approach when it comes to designing orbital vehicles. And Daniel Faber from OrbitFab focused on standardization as a key enabler for refueling in space. Here's what Antonino thinks about it.
As we venture in more complex activities, such as lunar activities, space resources, but also mega constellations, and in general, the increasing congestion of the orbit, there is a need for a centralized and streamlined mechanism. Because if the information is not organized in a database, does it really exist? Is it really useful? If I have to put it together myself, when we're talking about thousands and thousands of objects, for example, related to mega constellation, or when we're talking about very complex and extremely technical activities on the moon, if this information is not organized, and if we don't all share the same level of information, then the whole system, I wouldn't say it's useless, but it cannot be as effective as it should for safety and sustainability. For the moon in particular, I think that we all accept the fact that we have to find a common understanding. And so everyone is very willing to do that. And so even in the Artemis Accords, for example, which are obviously driven by a group of countries which are more developed, that actually have the resources to go to the moon, everyone is welcome to join. You don't need to have the money to participate in the Artemis program to be part of the Artemis Accords. And that is something that most people don't really reflect on, because the Artemis Accords, yes, the text is there, but the implementation of the Artemis Accords is decided by consensus by the Artemis signatories. That means that if you will probably never go to the moon in the next 10 years, but you will have the same voice, at least on paper, than the United States, because they will literally sit around the table and say, how do we implement Section 10 of the Artemis Accords on space resources? And you can raise your hand and say, I don't agree with this. And if others join you, and if there is now a group of emerging nations as part of the Artemis Accords, then you can block decisions. You can say, no, you have to reason with us until we are happy. Same as you would do in COPUOS. So the same logic is applied even in a completely voluntary political alignment. Because again, I think no one will ever be able to say, you know what, we're just going to go and you have to deal with it. I don't think that argument will be solved.
Why do we need international coordinated efforts anyway? It is not only about a practical point of view of making the most of latest scientific knowledge and state-of-the-art technologies, but also sustaining a community approach. If we look back at the gold rush we started with, this aspect was not considered, to say the least. There are, of course, no indigenous people on the moon. However, before heading that way, society must have an inclusive dialogue.
So let me give you two situations. Imagine you and I work out rules, and then we go to 30 people and we say, okay, here are the rules. You have to abide by them. Right? And those 30 people have had absolutely no input, right? And we are imposing it on them. Okay. No matter what we say, they are less likely, or they will have resistance, right? We've got no ownership in this. We've had no opportunity to contribute. We don't accept your premises, whatever. If, on the other hand, you and I and those 30 people sat down and we had a discussion where they would at least have the opportunity, they may not decide to say anything, but they'd have the opportunity to contribute. Of course, we're going to disagree. There are going to be different perspectives. We've got to negotiate, etc. There are compromises. But if in the end we come up with something, then because they've had the possibility to contribute, they've been at the table, they have skin in the game, they have had the opportunity to have inputs, they are far more likely to abide by our rules. Having a common framework that everybody has had the opportunity to contribute to is one way of lessening the risks. And by lessening the risk, you then automatically maximize whatever benefits might come. Indigenous people have been able, for example, to find water sources. And in a sense, the colonizers never listened to that knowledge and, got it all wrong. And so there's an incredible sense of knowledge. There's also an incredible sense of stewardship and custodianship. Indigenous First Nations people around the world, I can't speak for all of them, but certainly in Australia, see themselves as stewards, as custodians of their surroundings. They are part of it. They are part of it. And they see that, we must consider allowing this environment to be enjoyed going forward.
It's clear that there are numerous challenges that lie ahead in our quest to harness and utilize space resources, and the timeline is still uncertain. Be it from the gold rush of centuries ago or our activities in Antarctica, we have a chance now to learn from past mistakes.
I think you need to balance this is what we should do and with this is how we're trying to get there in a realistic way. I don't mean to sound like a party pooper, but I think you've got to meld that idealism and realism together.
With this 6th episode of Resourceful, we mark the end of our mini-series, or at least for the moment. Be part of the conversation, reach out with suggestions of topics we could explore in a potentially new season, and share the podcast with your friends.
This series is brought to you by the European Space Resources Innovation Centre, ESRIC, supported by the Luxembourg National Research Fund, FNR. It is produced in collaboration with Silex.